everyone. I am Payal from Section C, presenting you my business analytics project. So, in today's data driven business environment, organizations increasingly rely on business analytics to gain insights, improve their performance, and support strategic decision making. So, this project presents a integrated business analytic approach by applying multiple linear regression MLR, that is a supervised technique. Second, the factor analysis, which is an unsupervised technique. And then Power BI dashboard presentation across diverse data set. So this project has been divided into three parts. The part 1 consists of the multiple linear regression, the part 2 consists of the factor analysis, and the part 3 consists of the Power BI dashboard. Let's go through the abstract of the project. First, this aims to demonstrate the practical application of business analytics techniques and integrating all these techniques together to get a proper result and implement it to take strategic decisions for further use. The introduction. In today's data driven world, we heavily rely on data, the business analytic techniques to improve our performances. So, similarly, we are using the three majorly the two techniques, that is one supervised model, that is MLR, and second one is the factor analysis, and the third one is the Power BI dashboard. Let's go through the objectives of the study. To apply MLR for predictive analysis and identify key factors that influence the business outcomes using the Nestle stock prediction dataset. To perform factor analysis on the wine quality dataset in order to reduce the dimensions and uncover the underlying latent factors affecting product quality. The third one is preparing an interactive Power BI dashboard and analyzing the OTT platform data. Fourth one is statistical modeling, multivariate analysis, and business intelligence tools in solving real world problems of business to enhance the data driven decision making by transforming raw data into actionable insights. Let's go through the scope of the study. The scope of the study is limited to the application of selected business analytic techniques, namely the MLR, factor analysis, and business intelligence visualization using the Power BI dashboard. This project utilizes secondary data sets collected from Kaggle, including the Nestle prediction stock prediction data set for MLR, the wine quality data set for factor analysis, and the OTT platform data for Power BI presentation. So let's start with the part 1 of the project, that is the multiple linear regression analysis, which was conducted using the Nestle prediction dataset. Let's go through this dataset. So here is the Nestle prediction dataset where we first loaded all the necessary libraries, and since we are conducting a multiple linear regression, we need the linear regression model, then train test split, and we need other matrices, that is mean absolute error, mean square error, and R2 square for linear regression, and F1 way ANOVA, because this is a linear regression model, we need ANOVA table for it, so we have imported the F1 way ANOVA. Then the regression summary. So first we started by reading the data set, that is PD, which is pandas, and then looking at the head of the data set. As we can notice that there are so many variables here, that is the open price, close, high price, low price, WAP, number of shares, number of trades, and so on. And the head gives the first five readings, and the tail gives the last five. Next, we look at the shape of the data, that is the number of columns and rows, then the size of the data set. Coming to the info, it gives us the data type of each column. Then describe gives the descriptive statistics of each numerical column. Since all of these are numerical data, we have got the descriptive statistics for all the column. Starting with the data cleaning, we first clean the data by checking if there is any null value by using isNull.sum. So after giving this code, we see that deliverable quantity and percentage deliverable quantity to traded quantity has two null values. Going back to the info, we see that both of these 8 and 9 columns are float, that is, they are numerical data. So further, they can be converted uh, from non-null to from null values to non-null values by imputation. And we have converted the data, the date to date time function by converting year as a separate column, month as a separate column, and week as a separate column. And we can note down the changes here after using the date to time function. Then we drop the date column. Now let's define the numerical columns where we select all the integers and floats. Coming to the exploratory data analysis part, we start by plotting histograms for various numerical columns. And let's look at the first one, where distribution of the open price. So this is a histogram for the open price, and we did similar histograms for all the numerical columns. Next, we moved on to the box plot. Similarly, we plotted the box plot for all the numerical columns of this data set, and we did this to identify any outliers in the columns. The third one is the correlation heat map, where we have to analyze the interrelationship between the two variables, whether they are positively correlated or negatively correlated. Then we start by defining our y and x. So in this data set, we have chosen y as the close price and x as the remaining independent variables apart from the close price. Then we train and test the data by dividing it into in the ratio of 80 and 20. Then we standardize by using z-score. Then we fit the model using the x train scale and the y train. And then we predict the model. Then we find out the matrices required for the MLR model, that is the mean absolute error, mean squared error, and R2 square, that is coefficient of determination. We see that coefficient of determination is 1, mean absolute error is 0, mean squared error is 0. So this is the regression summary. So as we noticed, the R square, which is the coefficient of determination, is 1 with MAE and MAC values of 0. So this indicates that model predicted perfectly the close price on the test data set. So which shows that this is overfitting of the data set, which is quite suspicious and typically points towards issues like data leakage or severe multicollinearity. So upon inspecting the model, the open price, which had high large positive coefficient around for 49,029.73, the spread close price was having a positive coefficient of 159.99. So this shows that because the R square is 1, taking Y as the close price, which shows that this is making forecasting useless. So we need to choose a better model for it. Now let's move toward the second part of the dataset, that is factor analysis on wine quality dataset, which consists of multiple quantitative variables related to the chemical properties and quality characteristics of wine. These variables collectively influence the overall quality rating of wine, making the dataset suitable for multivariate analysis. So let's look at this dataset in Python. So here again we started about by importing the required libraries, pandas, numpy, and PCA, which is principal component analysis, then standard scalar for standardizing the data, and factor analyzer, and KMO. So we started by reading the data set, then checking for null values, and looking at the data set, we see that all are numerical variables, and there is no x or no y. That is, this is an unsupervised model, so we don't have any predictor or response variables. This is an unlabeled data set. So then we start the factor analysis. But before starting factor analysis, we look at the data set properly, and we see that there's a quality column at the end here. So taking this quality column would make it unsuitable for an unsupervised technique, that is factor analysis. So before starting factor analysis, we drop the last column of quality, and here is the, and then we use it for the factor analysis. So we check for the KMO model, calculate KMO, and then from factor analyzer we also calculate the Bartlett's Pearcity test. So the Bartlett chi-square test value is 26,470 and the p-value is 0. Then we have to scale it. So we download the PCA. Method 1 is the Kaiser criterion, finding the eigenvalues. Then we find out the eigenvalue and plot the scree plot. Here is the scree plot. Then we have to find out the loadings, the components, and then apply the factor analysis for n factors is equal to 2. That is, we have brought down so many factors to 2 factors by reducing the number of extra unwanted factors to 2 factors. So this is the usefulness of principal component analysis, where we do the dimension reduction, and here's what we have got from the loadings. Then we find out the communalities for each variable, and then the variance factor. So the objective of factor analysis primarily was to reduce the number of observed variables into a smaller set of meaningful factors and not including the unwanted variables, identifying the latent variables that influence wine quality, simplify data interpretation, and while retaining the maximum information. So before performing factor analysis, the suitability of the data set was evaluated using these two techniques, that is the key test, that is Kaiser-Meyer-Olkin test, and the Bartlett test. So KMO value indicated that adequate sampling adequacy, confirming that factor analysis was appropriate for the data set. So here we have this value is below generally accepted threshold of 0.6, a low KMO. So which indicates that common variance share among variables is not very high, suggesting that the data might not be ideally suited for factor analysis. Next, we look at the Bartlett test, which has a highly significant p-value of 0.000. P-value is less than 0.05. This result led to the rejection of the null hypothesis that the correlation matrix is an identity matrix. In simple terms, it confirmed that there are no significant interrelationship among the variables, making factor analysis statistically appropriate for identifying underlying structures. Next, come to the factor extraction and rotation. So factor extraction is carried out using the principal component analysis PCA. Factors with eigenvalues greater than 1 were trained for analysis. To improve interpretability, factor rotation was applied, resulting in clearer structure of variable loadings. The rotated factor matrix helped in identifying various groups of variables that load strongly on specific factors. Now We have got these four factors identified for retention. The eigenvalues for these factors were approximately around 3.22, 1.58, 1.22 and 1.02. Next, factor analysis and Varimax. So factor analysis with determined four factors and a Varimax rotation. Varimax rotation aims to simply the factor structure by maximizing the variance of loadings within each. So factor 1 is the alcohol density factor. The loading density was 0.679 and a strong negative loading from alcohol minus 0.979. So inverse relationship between these two tend to have a lower density. Factor 2 is sulfur dioxide factor and critical preservative in wine production. Then because it has the factor is highly loaded with total sulfur of 0.89. The third factor is acidity factor, which shows a high positive loading while pH is negative loading. Then factor 4 is sweetness body factor, that is residual sugar is 0.9 and density is 0.5, which shows a strongly load on this factor. Now let's move on to the third part of the project, that is the Power BI dashboard. In the era of digital transformation, business intelligence and analytics both play important role in converting raw data into meaningful insights that support strategic decision. This project focuses to design and develop an interactive dashboard to analyze movies and TV across multiple OTT platforms, and the data was collected from Kaggle. The objective is to demonstrate the practical application of business intelligence Power BI concepts using many methods such as data cleaning, modeling, visualization, and insight generation. So the dashboard provides a consolidated view of content distribution, the genre popularity, performance, the platform wise comparison among different OTT platforms, and the content type analysis, that is whether it's a movie or was it a TV show, enabling different data driven understanding of OTT content. So let's have a look at the data dashboard. So this is how a dashboard looks. So before starting the dashboard's presentation, I would like to tell that first we had only the six CSV files loaded into the data, but then later on we created other needed necessary files and a few quick measures and a few DAX query and as well as new tables necessary for required for the data dashboard. So now looking at the Hotstar column here in the side data bar, we had only few columns over here, but then later we had to create other columns, other quick measures such as count of title for movie, count of title for movie 2, which was the TV shows, then um, count of TV, then count of total genre to calculate the percentage grand total count for the genre and titles. So after creating all the necessary measures and tables, we headed to start preparing our dashboard. So this is the home page, which consists of these two images, which one will lead you to the overview, this cinema image, and the second one has all the OTT platforms. So if I click on control and then click, this will lead me to the overview page. Similarly, if I go to this home bar and control click, then I will be back to the home page. Again, if I click control and click on this image, it will lead me to the OTT platform. These are the four major platforms, that is Disney Hotstar, Netflix, Amazon Prime and Apple TV Plus, which I have taken for my study and presenting in the dashboard. So let's start with the presentation. Let's start by the first OTT platform, that is Disney Plus Hotstar, by control plus clicking on the first icon. So this led us to the Hotstar's page. We can see that these are the images which have been put here, and then we see the total number of movies, the total number of TV shows which are being placed in this card visuals, and the genres, the types of data, and also the slicer, the date slicer, the year slicer, which can be moved across, and we see that the values will change. Then we have the total number of movies and shows released each year, and the rating by total shows. The total shows in the sense the total number of movie and TV separately and their ratings. Then we look at the percentage of the count of movies and TV total shows. Then the total shows by genre and total number of movies and TV in this gauge. Here we have these two visuals. This one, the first one which is being selected here, which is known as the word cloud analysis. The purpose of this visual is to identify the most frequently occurring genres or keywords in OTT platform dataset. It quickly provides intuiting advantage understanding of content popularity based on the text data, and then larger words represent genres or keywords with higher frequency. Once the play axis is played, we'll notice the changes, and then the smaller words indicates which have very less frequency. So here we can see that drama is in large size, the word drama, that means it has higher frequency, which is that drama is watched more in Disney Plus Hotstar. Next, coming to this play axis, which is another visual which is not there in default by the in the Power BI, but we have to install it separately. So play axis in Power BI is used to analyze how data changes over a selected sequence, typically across time such as release year or genre in this case. So once we play this, automatically it plays as a video, and all the values in the uh, once the play axis is played, we see changes in the numbers. Just look at the changes. Now let's control click and move to the next OTT platform, that is Netflix. So here we have landed to the Netflix dashboard, so which represent that Netflix has the largest content library among the three platforms. Movies constitute of a significant portions of the Netflix content, along with a strong presence of the TV shows as well. Certain genres dominate Netflix catalog, reflecting global audience performance. So the main interpretation is Netflix has this diverse and extensive current content portfolio, which indicates a strong focus on audience retention and a global markets reach. The balanced mix of movies and TV shows supports binge watching behavior. So the recommendations could be continue investing in original series to strengthen brand differentiation, then expand your night genre offerings to cater to segmented audiences. We can see we have this total genre, total director, total cast, which is almost 25.45k, and the number of countries are 109. The yearly release has been increased, and here the country map which shows where is the Netflix available across all the world. Then the ratings. Next, let's move on to the third one, that is the Amazon, by clicking Amazon. And here we have landed to the Amazon Prime video dashboard analysis. Here we have rating by total shows, then the date slicer, the movies and the TV's percentage in this donut chart, the total shows by country, the genres by total shows, and the total shows by release year. So, Amazon Prime Video has shown us a moderate content volume compared to Netflix, which was quite high. A higher emphasis on movies is observed compared to TV shows, which has a very less uh, show here. Genre distribution indicates a mix of mainstream and regional content. So, Amazon Prime Video strategy appears to focus on providing diverse content while leveraging language and regional specific offerings. Increase the number of TV show and original series production because TV shows content is quite low compared to movies. Then use genre insights to optimize content acquisition costs. Now let's move on to the Apple TV, the fourth platform. So here we can see the genres were 97, average runtime 51.11 minute approx, and the runtime of different shows have been given here. Then we see movie released in different years and the rating of the total show along with the slicer of the year. So Apple TV has a smaller but more curated content library. Content is concentrated in selected genres only. Highly it focuses on original and premium quality of content. Apple TV emphasizes quality over quantity, targeting premium users and focusing on exclusively rather than volume. So they mainly focus on quality over quantity. They maintain a to maintain strong original content strategy is my recommendation, and then using data insights to expand selectively into perform high performing genres. Let's move on to the overview. So here's the overview report view. So overview dashboard here provides a consolidated view of the OTT platform content. It summarizes the key metrics such as the total movies, count of genre, total revenue, the sum of revenue by score, and average revenue by original language, which is represented in the heat map. Then we have this title slicer where if we select alive, for example, we can see the necessary changes. Then we have this total movies by language in this pie chart, which shows the different languages overall. Now let's control click and move to Hollywood. So Hollywood dashboard focuses on analyzing the Hollywood movies based on budget, revenue, IMDb ratings and general performance to understand profitability and the content success. So high budget Hollywood movies tend to generate high revenue. We have this date slicer where you can adjust this and look at the required changes. And we also have the count of genre, the genre slicer where you can select your required. Suppose if I select action, I see the necessary changes which is happening. Then we also have the title slicer and the language slicer. And apart from this, we also have the play axis. Let's play this axis and look at the necessary changes, which is for country. As we can see that the visuals are changing, the values on them are also changing after clicking on the play axis. Now let's pause this and move to Bollywood. Now control click on Bollywood. So here we are landed on the Bollywood page. The Bollywood dashboard analyzes Indian film content based on genres, IMDb scores, budget, and revenue to understand regional content. So, looking at the map here, we see country India in the map. That is because we find Bollywood movies majorly in our country. So we have only this country highlighted, India highlighted in the map. A limited number of genres dominate Bollywood content. IMDb scores vary across genres, indicating diverse audience preferences. Budget does not always guarantee higher revenue, emphasizing content quality. So, one interpretation is Bollywood content success depends not only on the budget but also on storytelling, genre appeal, and also the audience connection. Regional preferences strongly influence performance. So recommendations could be invest in content's quality rather than only on high budgets. Explore emerging genres with growing audience interest. Use analytics to reduce the financial risk in content production. So overall, the overview is that we can use business intelligence tool in greater uh, way so that they can provide us with both the macro level and detailed insight. These dashboards support strategic decisions related to content investment, diversification, and performance evaluation. So, concluding our project by saying that how analytical tools can transform raw data into actionable insights for strategic and managerial use. And learning outcomes are applying the practical experience to the MLR for predictive analytics, dimension reduction for the data set of wine quality, then hands-on experience on Power BI dashboard use and using quick measures and DAX measures, then enhance the ability to transform analytical result to business insight, improved understanding of end-to-end business analytics life cycle. So thank you.